Hey, astronomy folks. We're going to talk about Newton's universal law of gravity real quick here. So I'm going to get right to it so that we can start working on some of the practice problems. Okay, let's see here. Here is the formula. Now, you don't need to memorize this. I'll never test you on the memorization portion of this formula. I just need you to know how to manipulate it, how to use it. All right, and it's a little scary looking at first until you break it down. Okay, now my handwriting is beautiful. I understand that, so I'll try to do the best I can at translating my beautiful handwriting here. But so here are all the different pieces. Okay, take a picture of this, write this down, whatever you want to do. But what the formula is solving for is the force of gravity, right? That's what Newton's law of gravity is, and what Newton's law of gravity says is that basically any two objects that have mass have at least some gravitational attraction towards one another. So when you hear it that way, right, when you realize that any two objects that have mass in the universe has at least some gravitational attraction, that means literally that all of us have a connection with every other object with mass in the entire universe. Right. I actually think Obi-Wan explained it really well in this scene here of Star Wars. If you haven't seen this movie, you just failed astronomy.
Surrounds us, penetrates us, it binds the galaxy together.
Oh, look at Luke. He's like, oh my God, Newton is amazing. Literally what he's thinking right there. And I can't agree more. All right. So back to this. So that's what the force of the formula is trying to solve for, right? It's force of gravity. It's solving for newtons. Now, newtons is like the metric version of pounds, okay? So it's the gravitational force. So it makes me wonder, so what's the difference between weight and mass? Well, weight is the gravitational force, right? I have a weight on Earth, but I have a different weight on Mars. My mass, though, my mass is what my body is composed of. How many atoms make up me, right? And it doesn't matter where I go. If I go to the top of a mountain, or if I go to Mars, or if I go anywhere, I'm taking my mass with me, okay? Some people call it fat mass. I'm taking my big fat mass with me. But anyways, I'm going to take that mass with me. And that's why my mass never changes, because I'm taking all of these atoms with me. Okay. All right. So that's the difference between weight and mass. So we're going to focus really on mass in the formula, but we're going to determine the weight in newtons. G is a constant, right? You certainly don't need to memorize it. It's Newton's gravitational constant. And it's a complex number, 6.67 times 10 to the negative 11. It's a super small number, right? And it's newtons times meters squared divided by kilograms squared. That's the unit, all right? So then we have the letters M, M1 and M2. That's the mass of object 1, the mass of object 2. And then R. I write it as R, even though it's distance. Because usually when I'm using this formula, I'm talking about how much would you weigh on whatever planet, right? And when you do that, it's easier to think of distance as the radius of the planet. So I usually use R here, okay? So it's going to end up always being whatever the planet is going to be the radius of the planet, because the center of gravity between you and planet Earth is really the center of gravity is the center of the Earth, because Earth's gravity is so much more than our gravity. So that's what we use. We use the radius, okay? So question, how much would that's me. How much would I weigh on the moon? Okay, so we got to go through some facts here. Okay, how much would I weigh on the moon? Okay, well, first off, my weight changes on the moon, but my mass doesn't. My mass is always going to be 100 kilograms. All right, now, between you and me, I think I weigh more than 100 kilograms. I think my mass is more than 100 kilograms, but that's neither here nor there. Let's pretend it's a nice even 100 kilograms. Anyways, my mass is 100 kilograms. How much would I weigh in newtons if I went to the moon? Well, here's some basic facts you can get anywhere. The interweb is a good place to go for this. You can Google something like, all right, what's the mass of the moon? Boom. What's the radius of the moon? Now, the key is that what you have to understand is that when you're using this formula, because the gravitational constant is measured in meters squared, you have to make sure that the unit for the radius or the distance is in meters. Okay. Almost always they're going to give it to you in kilometers, right? And then, of course, 1 kilometer is 1,000 meters. So all you have to do whenever they give you a number in kilometers, multiply it by 1,000, and that's the number in meters. Okay. So here's what the formula would look like if I'm writing this out, okay? But not necessarily what it would look like when I type it into my calculator. Here's what it kind of writes out to look like, right? 6.67 times 10 to the negative 11 times 100 times 7.36 times 10 to the 22, all divided by 1.74 times 10 to the 6 squared. Blah. That's a lot, right? So that's not how I would type it in my calculator, but I just wanted to show you what it looks like all written out. And I want to see how, I want to show you how all the units kind of cancel out. This is meters. I forgot to write that in there. But anyways, you have a kilogram here and a kilogram here, and they're on the opposite side of this fraction right here. So these actually, this kilogram squared cancels out with these 2 kilograms right there. Okay. And then you have a meter squared on top here. You have a meter here, but then it's going to get squared. So the meters cancel out like that. And so all that's left is newtons. All right. So how do I type this out in my calculator? All right. You don't want to do times 10 to the power of anything because your calculator is too smart. It's actually going to think too much. All right. So you gotta simplify things a little bit for your calculator, and you're going to type it in like this. Okay. And here's my calculator. Hopefully, you see that light's kind of, I don't know what's best. That might be the best. Okay. So anyways, here's how I would type this out in my calculator. All right. I'm going to open up a parentheses. All right. I'm going to type in 6.67. Now, instead of typing in times and then 10 and then the caret button, which is the power, and then negative 11, all I have to do is push the second button and this button right here that says EE. All right. When I do that, it gives me this capital E. That means like exponent, right? Well, what that capital E actually means is times 10 to the power of. So you don't have to write times 10 to the power of. Okay. You already have that taken care of. So you just have to type in the number. So 6.67 times 10 to the negative 11 is 6.67 E to the negative 11. Okay. Then you're going to multiply it by my mass, 100. Multiply it by the mass of the moon, times 7.36. Second button, EE. And then I'm going to type in 22. Okay. I'm going to close the parentheses. I'm going to divide. All right. I'm then going to type in the radius squared, keeping in mind that this should be in meters. That's one of the biggest mistakes is people forget to convert to meters. All right. I've already done that for you. Open up the parentheses, 1.74 second E to the 6, close. And then I'm literally going to hit that X squared button right there to square the denominator. Okay. And when I do that, I get 162.15-ish newtons. What did I say? 162? So I'm just going to say 162 newtons-ish. Okay. But what the hell's a newton? I don't know what a newton is. I can't visualize a newton. I don't know what a newton is. Well, a newton is about 4.45 times a pound. So if I want to figure out how many pounds 162 newtons is, all I have to do is divide it by 4.45. So I'm going to take this handy calculator, hit the divide button, 4.45, and boom, I would weigh 36 pounds on the moon. I've lost a few moon pounds. I just want you to know. Actually, I probably gained a few moon pounds, but between you and me. All right, folks. It's been fun. Thanks for laughing at my fat mass. I appreciate that. It brings me a lot of joy, a lot of love, a little bit of anger, resentment. All right, folks. I'll see you again next time. All right.